I think it's okay now.
Yes, sir.
Tanzil? Okay.
Yes, sir.
Okay. Now obtain the output C by R. That is output is C. R is input using block diagram reduced block diagram reduction technique for the following figure. So we have to obtain this. Now you can clearly see that this is input from this side R, and this C is input, and this is the arrangement. Now what we will do first here, first of all I will do some numericals, then you can also try. So let's start the solution of this numerical. Okay, let's start the solution of this numerical. Now out of this we can see that this takeoff point, let's say this is a point A here. Okay, now we will shift the takeoff point A from the position before a block to a position after a block so that we can make it here. Okay, so we have to see that. So first point here is shifting, just to make just to simplify the circuit, we'll say shifting takeoff point A from a position before a block to a position after the block G1. So G1 is the block, this position is here, so we'll move it here. Then what will happen if we move a takeoff point beyond a block, then it will be divided by that transfer, uh, one reciprocal of it will be the reciprocal of this transfer function that we have seen already. So this signal will come here and a transfer function will exist whose value will be reciprocal of this one. So let me draw this first. Okay, I have first to draw the uh, this one, two circles I will be drawing. So these are two circles for takeoff points. Now this is a summing point. This is also summing point. Okay. So here we have input signal. First we'll be doing, this is an input signal, plus minus. Here we have plus plus. Now what we'll be doing, this will remain as it is, the signal. Okay, then we have a block. Here we have a block. Okay, we'll move this to here position. Okay, and then again we have one more block. Okay, then this signal, rest of the things will remain same, just what I have told is going to only change. Then we have a block here. Okay, then we have output. So these are not going to change. What is going to change here is, this is input, this is G1, this is G2, this is G3. So we had a feedback here from this point. We had a feedback. So we can take that feedback, H1. So we had a feedback like this. Okay, now let's take that feedback block. Join this. Okay, this is H1. Now, what we have done here, this takeoff point from position A, we have moved. Let us say this is a position B. Call it a position B, no problem. Position A to position B. So position, this takeoff point will move from here, and this takeoff point will be like this. So this will become like this. What will be multiplied? It will be multiplied by a block whose value we already know. We have done that. Whose value will be reciprocal of the transfer function of that block where we have transferred it. So this signal here, it will move to here, and then things will remain same. That means the signal is going towards the summing point. Signal is going towards the summing point. Very simple. So first step is over. Now what is the value of this one? This value we know. This is 1 when you are moving it. Where? When you are moving it ahead of block, it will be divided by that value of the transfer function of that block. Uh, if it is ahead, if it is beyond, if it is ahead, if it is before, then it is simply transfer function. So this is the first step. Now second step, you can see after second step, you can see this is a negative feedback loop. So formula for this is G1, 1 plus minus is there. So it will be 1 plus G1 H1. So this is closed. This is a closed loop here. Now, then second, we can say there are what you say forward, these forward forward blocks. They are adding to each other. See, this is a forward block one, same as forward block here. So they will simply add each other. So remaining will be this one. So next, what we are going to do, you can see here, this is a signal, and now here it will be a transfer function that will represent this closed loop value. That will represent this closed loop value. Then we have two blocks in forward direction. So we will write that two blocks in the forward direction will be simply added. We have this rule. So we will be adding these two. Here we can add them. So this is also finished, and left over will be only block, that is your G3 block having a transfer function G3, and output signal is going to remain as it is. Output signal is going to remain as it is. So let's write down, this is R. So this value is, this is a closed loop transfer function. You can see negative is there, signal is going towards a negative sign. So closed loop transfer function, the negative feedback is there. So formula for this one is G1 1 plus G1 H1. Where there is minus, it will be plus. Where there is plus, there will be minus. That is already we have done it. So this is two blocks are in forward direction. So two blocks are adding each other towards a summer. So we add them simply G2 plus 1 by G1. And this is going to remain as it is. Very simple till now. And output is as going to remain C here only. So all the three are in cascade. So we can multiply them simply. So all the three blocks are in cascade. We can simply multiply them. Signal. And then we have a big block. And then we are going to have an output block. Okay, so we'll take this input here. And this is your R, this is your C. You multiply them. So what you are going to get, G1, G3. Okay. Then this will be 1 plus G1, G2 divided by G1. So you can write down here G1, G3. This will be 1 plus G1, G2 divided by G1. So this will be 1 plus G1 G2 whole divided by G1, this G1, and sorry, whole divided by this G1 multiplied by 1 plus G1 H1. So if you want to simplify it further, then you can simplify it by G1 and G1 and G2 gets cancelled. So let me copy this block. This is, sorry, copy, and we are going to paste it. Paste. Okay. So here what G1 and G2 gets cancelled. We can cancel off this G1, G2. G1, G1, sorry, cancel. This will be G3 multiplied by 1 plus. So we can simply write in terms of the mathematical form. This is a block diagram form. In the mathematical form, you can write output, because we have to find that output divided by input will be G3 multiplied by 1 plus G1, G2 divided by G1, H1. So this is your output by input for the first. Very simple. It was a very simple. Just move the takeoff point. We are moving the takeoff point. With moving one takeoff point to the appropriate position, we have been able to simplify this within 3 steps. So that you have to look into. We can tell you the rules, other things, but you have to apply your mind also how the things will become more easier. Now let's talk about the second numerical. Just determine the transfer function C by R from the block diagram using block diagram reduction technique. So by using reduction technique, we have to again find C by R. Now, roll number 6, can you tell me what should be the first step?
Yes, sir.
Roll number 6.
Yes, sir. Assalamu alaikum.
Should be the first step. Jaldi. Time नहीं है इतना. हाँ?
समझ रहा हूँ.
जल्दी इतना टाइम नहीं है. We don't have so much of time left. यहाँ है ना ये टेक ऑफ पॉइंट, ये इसको यहाँ मूव करो. ये तो ये आ रहा है, क्या आ रहा है? कुछ ना कुछ तो आ ही रहा है. फॉरवर्ड ब्लॉक्स इन फॉरवर्ड डायरेक्शन है, ये सीधे जा रहे हैं. तो इसको यहाँ मूव कीजिए आप. सो फर्स्ट पॉइंट विल बी रोल नंबर 9. व्हाट शुड बी द फर्स्ट स्टेप? है यहाँ पर रोल नंबर 9? इज एब्सेंट. शिफ्ट द takeoff point after block G2 get to a position before block G2. This point we have to move to this point. So let us move it. I'll draw the diagram. We have 3 summers. Okay. This fine. So this is going to remain as it is. Fine. There will be a block here. Same block, we are keeping it same J1 block. So you can see block will be there. Okay, then we have a signal going to the another block. Two blocks are there. Okay, fine. Okay, so this is the scenario. Now what we are doing, this takeoff point, we are moving to this block, but let us do all other things rest now. This is plus minus. This is plus minus here. This is plus minus here. And this is plus plus here. You can see in the diagram itself. We are not doing, just moving this takeoff point. So I will move this here. But before drawing, I will draw a feedback signal from here. Okay, I have not drawn output here. Sorry. Output is taken from here. So let us get this. Okay. This feedback is going here. So this will remain intact. We don't have to do anything with these things. Now what we are doing, we are shifting this takeoff point here to the position here. So I'll shift this takeoff point now. Let me shift it. So takeoff point will reach to this position. There's a jump connection. And that takeoff point has a going to this one. But it will be a block now. Okay. It will be a block now. Okay. This is a jump connection. Let me write all the things first. This is your R. This is your G1. This is your G2. This is your G3. Okay, this is your C. Now roll number 9 is not there. Tanzib,
Yes, sir.
roll number 9 is absent.
एक सेकंड सर आई चेक
नहीं check करने को जरूरत नहीं रहने दो. He's not answering, then fine. Okay, tell me 27 Rutba. She is present और वो भी absent है. Rutba 27. He is also absent. 27. Okay, 35 Mac is there. Okay, what will this block will be having what value? Now there will I have told you, now we are shifting this takeoff point. We have shifted this from position this after the block G2 to a position before a block G2. What this takeoff point will have the value now?
G2 divided by 1 to H1.
It will be simply because we are taking it ahead of the block. So it will be multiplied by this. But here it is already here. When we are moving this, it had, sorry. Yes, it had a value of G1. So it will be multiplied by this G2 into H1. That is simply
Yes, sir.
G2. See, H1 was already there. So we have taken this takeoff point from the position this and move to a position before the block. So before the block, we multiply by the transfer function. So whatever there is in the transfer function, there is a feedback loop H1. So we have multiplied that one. Should be very clear. So this is feedback going like this. Sorry. Okay. So this was the scenario up to here. The next, Tanzib, roll number 10 is there. Roll number 10. What should be the next step, Tanzib? अभी
Yes,
मैंने
sir.
बताया इसमें क्या करेंगे ये there is a G2 and G3. What will
Yes,
happen
sir.
here?
G2 and D3.
They are
They are in
blocks in
parallel.
the
Yes.
forward direction.
Yes, sir.
So they are blocks in the forward direction. They will simply get added.
Added.
याद है ये rule कि नहीं?
Yes, sir.
So we will simply add them. They are blocks in the forward direction. ये मैंने आपको rule number क्या था ये? You remember it? I think you don't remember. कुछ rule number था ये. I don't. Yeah, this was rule number blocks in parallel. So this was rule number 2. So G1 and G2 will be added. Okay, we can do that. So let us copy this diagram as a whole. Let me copy this much only. Copy. And let us paste it here. Okay. So we have pasted it here. Instead of this G2, it will be what? Instead of G2, it will be now G2 plus 3. They are blocks in parallel, that they are in forward direction. So instead of G2, we have to write here, what we have to write? G2 plus G3. Rest will remain the, sorry. Okay, it will be G2 plus G3. So this will be G2 plus G3. After that, what we have to do, Shabash? Can anybody tell me? So we need to, oh, sorry, this summing point will also go. Yeah, because this is already done now. Okay, after that, what we have to do, can anybody tell me? शाबाश थोड़ा पहले क्वेश्चंस में टाइम लगेगा
सर टेक ऑफ पॉइंट पुट के समिंग पॉइंट के आगे लीजिए
No, we need to eliminate this summing point, which is after the block. Sorry, that we have already done. Summing point we have done. So next, what we have to do? शाबाश क्या बोल रहे हैं आप? Take off point कहाँ लेंगे?
समिंग पॉइंट के आगे
Very nice. That's all. Shift the takeoff point. Shift the takeoff point before block G2 plus G3 to a position after the block G2 plus G3. That's correct. So let me write it. Step लिखना जरूरी है. Shift the takeoff point before, which is present before block G2 plus G3 to a position after the block G2 plus. So we have to move it this position. Why? Because it will simplify. So I will copy this again. So let me copy this, copy, and I'm going to paste it here. Okay. So what I am doing now, I am shifting this takeoff point. So I will use the eraser. Oh, sorry, we do it. So I will shift this takeoff point where to this position before a block here. You can see here for those here up to here. I will make it to join here. So I will shift this. Just a sec. Sorry. Yeah. Just a second. I will move this. So I'm going to join this here. You can see this will be joined here. This will be joined here, and we will have the output. Sorry. We'll have the output here. So R is at it. G1 is here. G2 is here. Now this is going to change. This is here only. This is C. What will be the change here? Shabash. Now we are moving it from where? Before a block to after a block. After a block, what we do? We divide by transfer function. So this block will remain. What will be the value of this block now? Value of this block will be G2 H1 was already there, divided by simply by the transfer function value G2 plus G3. Please remember these manipulations. You have to remember them. Okay, let me edge a page. Okay, this is fine. So after that, what we need to do? Shabash. Very simple step is there. इस स्टेप को कुछ करना है. दिस इज ए क्लोज लूप ट्रांसफर फंक्शन. नेगेटिव फीडबैक से ये तो ट्रांसफर फंक्शन जा रहा है, यहां से फीडबैक आ रहा है. So this is a closed loop transfer function. So let me copy it. So this is copied. Let us paste it here. Okay. Now this closed loop transfer function has to go. So what will be the value? G2 plus G3, 1 plus, because signal is at minus, 1 plus, there is no feedback, feedback H1, feedback H is equal to 1, this is unity feedback, so that will be 1 plus G2, G3 into 1, so that will be the formula. So I will amend it, and let me use the eraser here. So this complete loop will go. Okay, so I will instead draw a transfer function. Sorry, I will draw a block here. So I will erase the signal here also up to here. This will move up to here, G1. Output is going to remain intact. This is intact, no change. This value will be the feedback value. We know that. What is that value? G2 plus G3. That is a transfer function, and feedback in this case is unity 1 multiplied by G2 plus G3. So this is the next scenario. Now you can see both of them are in cascade, so you can multiply them. I will copy again this. I'll copy this and I'll paste this here. I will use the eraser again. So here it will be a single block only now. You can see it's a single block. Feedback will not have any change till now. There will be no change in the feedback. So I will be drawing a single block here. That's a single block. Signal will be going like this. And in this case, these things will remain intact. Sorry. Okay. These things are going to remain as it is. So this value will be, this value is G1 multiplied by, these two are in cascade. Simply multiply them, divided by 1 plus G2 plus G3. Fine. Okay, Tanzib, now what should be the last step? Tanzib,
यस सर.
what should be the last step now?
सर ये और एक फीडबैक आ रहा है ना यहाँ से.
Feedback, इसको क्या कहते हैं? Clear cut. It's a closed loop transfer function.
क्लोज लूप था. यस सर.
Negative feedback है इसमें, तो we have to
Yes,
use the same. So we will use the same. So this is our R, this is our C. G1, H1. G1 divided by 1 plus G1, H1. So this is G1, this is H1. Let us see for the time being. So we will be writing here. Let's simplify first this one. So RC by R will come out to be, it will be G1, G2 plus G3, okay, divided by, okay, divided by 1 plus G2 plus G3, okay, whole divided by 1 plus G1, G2 plus G3, 1 plus G2 plus G3, okay, multiplied by feedback is G2 H1 divided by G2 plus G3. This is the feedback. So G1, 1 plus G1 H1, or 1 G, 1 plus GH. That's a formula. So we'll be using. Let us simplify it a bit. So we'll simplify this more. C by R in this case will be, okay, so we can write down in numerator, we can write down G1, G2 plus G2, G3. G1, G2 plus G1, G3. You can see. Now this, when we get the LCM of this will be 1 plus G1 into G2, G3. So here it will be 1 plus this G1, G2, G1, G3. This all terms multiplied by this term and divided by this term. So out of this 1 plus this will get cancelled. So if you simplify it, I'm not going to simplify it because it will take some time. You need to simplify it yourself. I'm going to write the value only. So this value will come out to be 1 plus G2 plus G3 plus G1, G2, H1. This value is going to come. So this is the value we are going to put here. This is the value of C by R. So this is the value of, we have to go put it in the block diagram. That means the value of the block diagram will be G1, G2 plus G1, G3, and that is divided by divided by 1 plus do you need to me to calculate this? Yes. Roll number 6. Can you do it, or I will have to simplify this also?
यस सर, हम करेंगे खुद.
It's very simple. If you otherwise मुझे multiply करना पड़ेगा, then I will do it. Can you do it with yourself? हाँ?
मुझे आएगा, लेकिन बाकी से भी आप पूछिए अगर उनको करना
Yes, sir.
होगा तो.
I think this is a simple mathematics. इसमें तो कोई elementary mathematics है ये. We want to save a bit time. आएगा सबको कि नहीं? Roll number 49.
Yes, sir.
Can you do it?
Yes, sir.
14.
Yes, sir.
Okay, then I think you should be able to do it. So mathematics only. Okay, so this was about the question number 2. So We'll be expecting this type of block diagram techniques, so we have to solve them. Now let's move to the question number 3. Okay. Okay, let me ask. Bisma, roll number 7.
जी सर.
Okay. बेटा आप मुझे बताइए, टेल मी व्हाट शुड बी द आवर फर्स्ट स्टेप इन दिस केस. ये ब्लॉक डायग्राम आपके, वी हैव टू रिड्यूस अगेन, वी हैव टू गेट C of S by R of S, that is output divided by input, we have to get it. We have to simplify it. What should be our first step? फर्स्ट स्टेप क्या होना चाहिए? शाबाश, टाइम नहीं है बेटा इतना हमारे पास, वी डोंट हैव सो मच ऑफ टाइम. Any other volunteer who can tell us what should be the first step? कोई भी नहीं है. That means you are not able to understand anything. Tanzib, roll number 6.
Yes, sir.
Yes, sir.
क्या प्रॉब्लम है? ये समझ नहीं आ रहा क्या हो रहा है इसमें. What should happen?
सर शायद जो G3 के बाद टेक ऑफ पॉइंट है उसको G3 से पहले लाएंगे.
Very nice. Shifting of takeoff point after the block G3. तो after the block या before the block, दोनों हम after the block करेंगे. That means shifting of takeoff point after the block. G2 के बाद जो takeoff point है उसको हम यहाँ ले जाएंगे पहले. तो let me do it. Yeah, you are correct. आप कौन है? वर्ड्स कौन सा बेटा? आंसर किसने किया है?
सर रोल नंबर 55.
ओके बेटा, वेरी गुड. थोड़ा दिमाग लगाना है. अदर स्टूडेंट्स ऑल्सो थोड़ा पहले लगेगा टाइम इसमें, ये एकदम नहीं आएगा. नोट एक्सपेक्ट कि सर ने अभी दिखाया तो हम ही. इस पर दिमाग लगाना है. रूल्स को अपने माइंड में, यू हैव टू कीप देम इन द माइंड एंड देन यू हैव टू अप्लाई द रूल्स. अ बिट मैं ट्रिकी तो नहीं कहूंगा, अब एक थोड़ा इसमें वी हैव टू look into the rules and then we should practice. We need to have practice also. Okay. This is output here. So there's a bit unity feedback, a bit there is a simple feedback. So we are doing what? We are moving this to this point. So that I will be doing. We are moving to this point. There is a negative feedback also. Okay, take off point, we are moving to this point. Sorry, this is arrow. So take off point, let me take off point, let me move this to okay. So this block will come up here. Whatever the value of the block will be there, that will be writing. But I'm telling that what I have done. And also we have a feedback here. We have a feedback here. And that block is going to remain intact here. Okay. This is here. So then overall feedback, we have unity feedback going to the first summer. This we can draw here. Can club it here with this one. Take it here. Okay. Okay. So this is the scenario we have. So this is now this time the RS is input as written above. Same I will write also. Plus minus this summer is. Plus minus this summer is. So this is your G1. Plus and minus above. This is your H2. Now this, we are taking this takeoff point where beyond a block. So when it's a beyond a block, we need to divide by the transfer function. What are the values here? That will be divided by the transfer function. So this value is H1G3. So H1G3, this is G2 because we are moving it beyond G3. It was before G3, we are moving it beyond G3. So that will be, if we move it beyond, the transfer function is divided. If you move before, it is multiplied. You have to remember this simple formula. So this is your G2 and G3. This is your C of S, and that is your output itself. Okay, I think this has simplified now. These are in cascade, and then again, this is a closed loop transfer function. We can solve this. We can take this in cascade and solve this closed loop. So I will take this step directly now. So I will copy this again. Let me copy this. Okay. Copy. And I'll try to paste it here. Okay. Now what is going to happen? This summer will go now. You can see here, these two are in cascade. This summer will go. Why? Because this is a closed loop transfer function and having a negative feedback. We know the formula of that. So I will be stepping it one by one, solving it. So here I will take off this summer. This alone will be represented by a single loop now, a single transfer function now. So I'll be writing this transfer function. Okay, I'll be drawing this transfer function here, presenting a block. There will be signal. Okay, fine. So then what does that mean? That means it will be, see here, you can have a look. G2 multiplied by G3 divided by 1 plus G2 G3 into H2. That will be, I think you should remember now these formulas. So G2 multiplied by G3 divided by 1 plus G2 G3 into H2. That's a formula of a closed loop transfer function which we have already done. This is R of S, your input. Rest all is same. So again, by solving this, by removing this summer, again these two are in cascade, and again this is a negative feedback loop. You can very clearly see. So let's solve this, and first let's solve this blocks G1 and blocks G2 G3 1 plus G2 G3 H2 are in cascade. They are in series, and then there is a negative feedback closed loop transfer function. If we solve that, we will get the value. So I will be writing the value. I need you to solve. I'll be writing that value. So let me copy. Sorry. So let me copy this whole. This is copied and this need to be pasted. Okay, this is pasted here. You can see. So what I'm going to do now, I'm going to remove this all because these two are in series, or we call them in cascade. This will be multiplied G1, G2, G3 divided by this. Then this is a closed loop transfer function, G1, G2, G3 divided by this 1 plus G2, G3, H2 divided by 1 plus multiplied by this H1. So that's the formula is known. So I will remove this all here. Instead of this, a single block will be, this all values will be represented by a single block by taking first the two values in the cascade and then using the formula of the closed loop transfer function. So this is, I'm drawing it here. So this is, okay. So this value will come out to be, I will write down this value. G1, G2, G3. I'm writing this directly. Please, some steps you have to solve just mathematically. Technically, you have to do nothing. 1 plus G2, G3, H2 plus G1, G2, H1. So this is, we are getting, again, this is a closed loop transfer function. Just a second here, I will write the C of S and I will complete this somehow. Okay. So again, this is a closed loop transfer function you can see with a unity feedback. Feedback loop is here, unity. So again, we will use the same formula. G, if whole is represented by G, G divided by 1 plus G1, H1. H1 in this case is 1. This is a unity feedback. So we'll write down here solving for a negative feedback control system with an unity feedback. So we can write this equal to, sorry, draw a block. Okay. So this is R of S, your input, C of S, your output. So what will happen here? This divided by 1 plus this. And if you solve that, that value is coming out to be, yes, this is G1, G2, G3 divided by, this is 1 plus G2, G3, H2 plus G1, G2, H1 plus G1, G2, G3. This is the value. If you want to solve it, you can also solve it. Okay. The value will be like this. Just a second, I'm going to use my battery. Battery is a bit down. Assalamualaikum sir, bu karo your phone mesh class chalan. So this is, you can see C of S by R of S is equal to G1, G2, G3 divided by 1 plus G2, G3, H2 plus G1, G2, H1 divided by 1 plus same thing. And feedback is unity. So that H will be multiplied. That value of H of S will be equal to 1. H1. Okay. So I think this is fine. Now, denominator will get cancelled with the denominator. The leftover will be C of S by R of S will be G1, G2, G3. Denominator will get cancelled with denominator and it will go up. So it will be 1 plus, sorry, it will be 1 plus G2, G3, H2 plus G1, G2, H1 plus G1, G2, G3. This is what we have got here also. So you can see this is what we can simplify a bit and you can get the answer. I hope with this we'll stop today's lecture. We'll stop